Let's look at a confidence interval problem. A quality control analyst suspects that the quality of gears that are manufactured on a Monday is less good than the gears manufactured on a Wednesday. In a sample of 300 gears manufactured on a Monday, 260 were ranked as acceptable or better, and in a sample of 400 gears manufactured on Wednesday, 92.5% were rated as acceptable or better. Let's construct a 95% confidence interval for the difference in proportions of gears ranked acceptable or better between Monday and Wednesday. And we're going to use this interval then to determine if the data supports the quality control suspicion that people aren't doing as well on Monday as they are on Wednesday. So, to start this question, to construct the 95% confidence interval, we should first ask ourselves the questions you should always ask yourself when you're doing a stats question. The first question, what kind of data are we looking at? What sort of variable is this, quantitative or categorical? So, I find it helpful sometimes to take a step back. Let's think about what the individuals are in this sample. We are ultimately looking at gears, and what we are measuring is whether or not the gear is rated as acceptable or better. So in this case, because we are looking at gears and we are measuring if they're acceptable or better is a category. This is categorical data. What we should also ask ourselves now is how many populations are we looking at? What are we comparing here? And it's pretty clear we're comparing Monday and Wednesday, so we are looking at two populations in this case. So this leads us to, when we're trying to decide which estimation methods we should use, we're going to use these two pieces of information to help us decide. So I'm going to go straight to Geogebra now to help us decide which type of situation we should look at. So you can go to geogebra.org/calculator, and then when you go to that, you want to click on the drop down that says graphing, click on probability, and then click on statistics. And now we want to decide which of these estimation methods should we use. Because I have categorical data, I'm going to be looking at one of the proportion situations. And because I'm comparing two proportions, I'm going to use the z-estimate difference of proportions. All right. So now ultimately we need to decide what we're going to plug in here, but first, before we do that, we should really be very clear about what our parameters are that we are going to be calculating. So before we go to the step of putting in data, I should take a moment to define what my parameters are. So I'm going to use the symbol P1 and P2. So I'm going to define P1 is talking about gears manufactured on Monday, and the parameter is a statement about the whole population, not just the 300 gears, but all of the gears. So P1 in this case is going to be the proportion of all gears manufactured on a Monday that are rated acceptable or better. And our P2 is going to be the proportion of all gears manufactured on a Wednesday that are rated acceptable or better. Key thing to note here is that because I'm talking about the population parameter, about the whole population, I'm talking about like all gears, not just the 300 gears, all gears. So we've got this set up. Our 95% confidence interval then is going to be an estimate of what the difference between these two are. If I could literally measure every single gear manufactured on every single Monday and every single gear manufactured on every single Wednesday and subtract those two proportions, we are predicting what that difference is going to be, what that subtraction is going to be. All right, so we've defined what we're looking at, and now, let's decide what variables we're actually looking at that we want to plug in. So we can start doing our computations. I'll say the number of successes. The symbol is going to be X1 in this case. They're saying this is Monday. There's 260 gears were ranked as acceptable out of 300 gears. So the number of successes is 260. And the sample size is 300. So that is what I will type in here. 260 successes out of 300 total. To find Wednesday, we're given the percentage. So in order to find the number of successes, I'm going to have to do a little bit of math. So x2, the number of successes on Wednesday, in this case, the number of gears that were ranked as acceptable, I'm going to have to do a little calculation. I'm going to have to do 0.925, that is the percentage converted into a decimal, times the sample size, so times the 400 gears. That will tell me how many gears were ranked as acceptable. So let's do that real quick. I'm going to compute 0.925 times 400, and that gives me 370. There were 370 gears ranked acceptable on Wednesday out of the 400 that we've got. So our sample size is 400. Our successes are 370. 370 out of 400. And Geogebra now computes for us our answer. So the confidence interval then, as an interval form, the 95% confidence interval is the result of the lower limit to the upper limit. So it is negative 0.1047 to a negative 0.012, and then a whole bunch of zeros, so I'm not going to round it anymore. So this is the interval estimate, but that's not really very useful for us in terms of actually interpreting what this might mean. So to start putting it into words, we're going to start thinking about what this means. So again, this is the difference in proportions. So this is telling us that we are 95% confident that the proportion of all gears manufactured on a Monday that are ranked acceptable or better. So I'm just going to copy that whole expression right there, this parameter run. We are 95% confident that this whole thing, the proportion of all gears manufactured on a Monday that are ranked acceptable or better, is, in this case, because this is negative, I'm going to state this, it makes more sense to state things in a positive sense, so I'm going to switch this to positive, and I'm going to convert these into percentages because it's more common to speak about proportions as percentages. So that is 0.12%, or sorry, I'm going to say is between, so it is between 0.12% and 10.47%. And now, because I changed the sign, I'm going to have to say what this ultimately is telling us. Maybe to go back slightly, this difference here, this is P1 minus P2. So note that it's entirely negative. And so, because it's entirely negative, that means that P1 minus P2, whatever that real difference is going to be, that must be less than 0, which in turn implies that P1, the proportion of all gears manufactured on Monday rated acceptable or better, must be less than P2, the proportion of all gears manufactured on Wednesday that are rated acceptable or better. So when I start constructing my sentence, I'm going to say, all right, I'm 95% confident the proportion of all gears manufactured on a Monday ranked acceptable or better is somewhere between 0.12% and 10.4%. And because I know that P1 must be less than P2, I'm going to say that it is less than the other proportion. So it is less than the proportion of all gears manufactured on a Wednesday that are ranked acceptable or better. So, in terms of constructing all of the sentence, like in other words, what this is telling us ultimately is that, yes, we have some evidence that there is a difference. The quality control analyst's suspicion was suspecting that gears manufactured on Monday is not as good as manufactured on Wednesday. And what we can see is, the proportion of all gears manufactured on Monday appeared to be less, that were ranked acceptable or better, appeared to be less than the proportion of all gears manufactured on Wednesday ranked acceptable or better. So ultimately, in other words, we can say yes, an answer to this question. We have some evidence that a higher proportion of gears manufactured on Wednesday are ranked acceptable or better compared to Monday. And again, we can say this because the confidence interval for the difference of proportions did not contain the number 0. The proposed difference, if we subtracted the proportion of all gears manufactured on Monday that were ranked acceptable or better, minus the proportion of all gears manufactured on a Wednesday that were ranked acceptable or better, if we did that subtraction, that result is some negative number. I don't know exactly which negative number it is. It's somewhere inside this interval, but it's definitely negative, which means that the proportion of gears manufactured on Monday ranked acceptable or better must be smaller than the proportion ranked on Wednesday, because a smaller number minus a larger number is what yields negative things, which means the second one must be larger. This tells us we've got some evidence at 95% confidence level that a higher proportion of gears manufactured on Wednesday are ranked acceptable. Specifically, that the proportion that's ranked higher is it's somewhere between about 0.12% and 10% are ranked higher. So this interval here, you might say it's not a significant difference, but there is a difference. It is better on Wednesday. In terms of trying to, just as then to conclude, or in conclusion then, to help us do this type of problem, you want to identify what kind of data you have, how many populations you're looking at. That will determine which of these different methods you're going to use. It's a very good idea to, right at the start, identify what your proportions are, what your parameters are, what you're looking at. Then you need to identify the successes and sample sizes to decide what to plug in. Sometimes you may be given percentages instead of a raw count, in which case then you need to take the percentage times the sample size to find the number of successes. This number will not always be a whole number. If it's not, just enter in decimal places. It's okay. Once you get your answer, you really want to ask yourself in terms of your answer, does the confidence interval of the differences contain 0 or not? If it's entirely negative, that means that the second one must be larger than the first one, because a smaller number minus a larger number is negative. If the confidence interval were entirely positive, that means that the first one must be larger than the second one. And if the confidence interval contains 0, that means that we can't say anything about, or we can say something about the comparison. It means that probably the proportions could be the same. But in this case, because it was negative, we can say that the proportions of all gears manufactured on a Monday ranked acceptable or better was less than the proportion of all gears manufactured on a Wednesday. All right, I hope you found this helpful.